All right, back again. We want to describe our relationship between the functions. So before we talked about, is it a function? Yes or no. Now, the function rule is that you're able to describe the operations performed to the domain value, the input, or as we like to call it, the x value. Okay, the x value. That's a little too thick there. Okay, this just helps us drive home that point of which is x and which is y. Okay, to get the range value or the output, which we know is our y value. Okay, and it can be used to write an equation. Okay, so this is our equation here, right? So now we have our x and our y here. Function notation is that instead of having your y value, you go ahead and you can see that they're replacing it with f of x. And if they put f4, means that when x is 4, what would this equal? So that's their way of, instead of writing x equals 4 every time, they just give you the answer right up front. So f of 4 equals 2x plus 3. So I would go ahead and just replace my 4 wherever x is. So I can go ahead and put 2 times 4 plus 3. Now, obviously, you can't just leave it like that. You're going to have to solve because you need to combine all your like terms. So f of 4 equals 11. Okay? Now, variable y and f of x both represent dependent variables, which means they can be on their own. If the example above, when x equals 4, f of x is 11. Okay, we solved that. This is just telling us in words, and it says you read it as f of x. Okay, this is read as f of x. Let's highlight that because we do not want to forget. We need to remember. So, look here. I give you some very nice picture examples. So, basically, it says that if f of 5 or f of x, if x is 5, what would you get? So wherever x is, plug in 5. Okay, you write the function, and basically writing the function is, instead of putting y here, you just put f of x. Okay, same thing here is f of x is -6. Okay, so you plug in a -6 for where the x is. Use your calculator for this, okay? Don't be afraid to use a calculator. Okay, you can use your calculator for the math, but this right here, this is showing your work. Okay, you must show your work. So now let's go ahead, and these are all you tries, right? So it's saying they want you to use this same f of x for both of these. So go ahead and write it in. F of x equals 14 plus 3x. F of x equals 14 plus 3x. Go ahead and solve, okay? That is just going to be plugging in this f of 4 for wherever x is, okay? And then this f of -7 for wherever x is as well. Okay, a function can also describe the relationship between two quantities. For example, the distance you travel in a car depends on how long you are driving in the car times the independent variable and the distance of the dependent variable. In other words, all that hullabaloo is distance is a function of time, or distance times time. Okay, so Mariah spends $22.50 downloading songs on her phone from an online music store for 90 cents each. Identify the independent and the dependent variables. Okay? So, since the total cost, right? The total cost is solely going to depend on how many songs she buys. If she buys 5 songs, the price is going to be different than if she buys 50 songs. So our function will say that the cost will depend on how many songs she buys. So that's how we want to write it. Cost depends on how many songs. Cost times songs. Okay? Use the function to determine the number of songs. So this is right here. It should be on the back side, but that's okay. So then go ahead and plug it in. If she spent, right, they give us the cost. They don't give us how many songs, so plug it in. $22. If she spent that much, how many songs did she buy? Okay, so you're going to solve backwards, and then, of course, you will, over here, you have your $22.50 equals 90 cents per song. And to get the S all by itself, you got to divide by 0.9, which means S equals 25. So she downloaded 25 songs. This is the last one that you have to do on your own. Take your time with these, okay? This is what you need to do in order to find the function.